Hello, everybody. Thank you for joining me again. We're going to do some high school Algebra 2. We're going to look specifically at some function simulations. I am Leah Dix-White. I am the RC who's hosting for today. Thank you for joining. As always, we wanted to share with you all that KCM is the place to check out all the resources that you may need. We're here for Kentucky's teachers. We have a lot of resources that are available to teachers and coaches or whomever works in mathematics education from pre-K to post-pre-K. So I'll be making reference to our resources later on in the presentation, so hang out for that. And as always, you can check it out before, during, and after. We have all of our sessions online that we're doing with you all, so you can access those as well at any time. And you can contact any of us if you have any questions moving forward. So what are we going to talk about today? We're going to look at some simulations with the KY.HS.F.8 website. I think they're really cool, and I think they provide for students lots of entry points into learning Kentucky standards in math and science. So we're going to talk about those, really looking at a task that explores transformations of functions. So we'll talk about that and some generalizations, and I'll walk you through a couple of those simulations. If you have access to the PowerPoint, everything that I'm going to be talking about is linked there and hyperlinked throughout the slide. I have a tendency to talk fast, so if I'm talking too fast, just kind of give me a notion in the chat, Leah, slow down, I can't keep up. Or if I go to a screen too fast, let me know, because I have a tendency to do that. So what is the research that grounds the work that we're talking about? Of course, NCTM publishes the principles to action, and that's what we go by, and we use that to reflect upon our teaching practices as well as the student mathematical practices. And all of our work is grounded, of course, in our Kentucky standards. But I wanted to look at computer math games and how they may or may not affect math achievement, particularly for high school kids. And so I know some of us were in sessions earlier where we were talking about math fluency, because we're in this book study about that, and there's a lot of emphasis on math games. And so I began to think about, what about computer math games for high school kids, and what does research say about that? And so that's when I stumbled upon this study that I've referenced here. And in this particular study, they're saying that there was a positive significant effect. So keeping that in mind, although the simulations that we'll be looking at aren't particular games, I'm going to make reference to one game later, and maybe that's the link that could provide the context for our kids. Who knows? Well, the standards that we're looking at today have to do with transformations of functions. And so that's what you're seeing in your slide. And also, we're going to be looking at the Student Mathematical Practice 3, which is constructing those viable arguments and critiquing the reasoning of others, and also MP5, which is using appropriate tools. And those tools would be the digital simulations from the KY.HS.F.8 website. I also threw in a little Desmos in there too, just to keep it spicy. So we'll be looking at some Desmos stuff, and as well as the KY.HS.F.8 simulations. And so when we're looking at how the functions are transformed, we're looking at these values of K or C or whatever constant, and how they may or may not affect functions and the graphs of the functions. And we're going to look at that specifically using graphing technology and Desmos. All right, those are our standards. So let's jump right in. So here's our task. And I actually did not create this task. I got this task from a wonderful article, which you can get if you go to our website. I've uploaded that as something you can download. And it was in a mathematics teacher article. And they basically talked about using generalizations to develop conceptual understanding. So we'll be looking at that with this task. So basically, we're going to be looking at exploring transformations of functions. And here's our function here. It's a polynomial. And more specifically, we're going to look at how the graphs of each of the modified versions of f of x compare with the original. And so providing our kids an opportunity to explore And to do that digitally, now is a great opportunity to do that. So let's jump right in. Is everybody with me? If you got a chance to write the function down, you can, because we're about to jump right into a link. I have embedded a link here to the task. And so I wanted you to take a look at it here. And so what you see in this screen, I actually got this task directly from the article. It has here the actual function that was in the PowerPoint. And what's neat about this visual, if you can see it, is that these sliders help you adjust those values that can change the function. So here we can adjust the A and see what happens. We can adjust the B value to see what happens. And so the idea here would give kids an opportunity to play around with this movement, like the dynamic of movements we talked about last week, and then to make inferences about what happens. And so you can always undo, which I think is great for kids, but even giving them access to this link to play around with it and then guiding some discussion around what they see, I think could really help. And students could do this. They could access the site and either in a Google form or in a doc, write some observations about what they see so they can draw some inferences from that. Okay, so that's the first thing I wanted to show you guys. What do you think? Tell me about what you saw and how that could help with this task before I show you some other things. Anybody want to share? Anything? Let's see what's in the chat. All right.
Yeah, I love that Desmos always allows us to think about that what if. This is so technology rich that's when kids are able to see patterns in things, looking for what happens if you do something with it. And they're so, that's the brain that they have thinking about it. How wonderful. I adore that.
Okay, so that was the Desmos, but they can continue. So you might be saying, well, my students might need some experience with other functions, maybe not that fifth degree polynomial, maybe they need some other things. So that's where I threw in the function simulations from KY.HS.F.8. And so I wanted to give you the opportunity to think about how can we get students to make some generalizations about these functions. And so the question that you could pose to your kids is, how do the graphs of the modified versions of any function compare with the original? So the idea is that we saw what happened with the degree 5 polynomial. What happens when we look at the function of a line? And then I know this looks very abstract here, but it's basically the same visual that we looked at in the previous problem, just with the function h of x. And then likewise with looking at the graph of a quadratic. So the idea and what they were trying to stress in the article with this task is students need lots of examples before they make that generalization. So I'm going to show you first just the function basics. So maybe your students need this lesson scaffolded a little bit and they just need some ideas to understand how functions work. Let's go to this function basics simulation. I think it's really neat. And so what's neat about this, and obviously this can be used for middle school, even elementary school, is for students to practice just understanding what does a function do. So if I put this mirror here at the center, if you're following along with me, and I put this butterfly in, then I see what happens when I do that. Actually, that one doesn't do anything but mirror, but let's try this one. So here, this gives me a better example. It kind of rotates, so the function is to turn the object. And so I think this just gives kids a good visual of this whole input and output. And it's a very basic simulation, but I want to share that with you guys. Any questions about
cool.
Basics? I know that was kind of quick, but I had some others too. I think that just gives kids a context. And what I think about these simulations, the kids can play around with it, right? And since we're in this non-traditional instruction learning environment, this can be something you could post for your students to look at and play around, and then just answer or ask questions or challenge others with. So that's just function basics. So, okay, so kids are kind of getting some ideas about what a function does. So let's look at graphing lines. We're looking at the function h of x here. And so this is a simulation that I thought was really cool because it helps kids explore those parameters of functions, and there's lots of different forms of the function, right? So in the PowerPoint, I just had, you know, the slope-intercept form, but you can look at various forms. So what I think is cool here is you can play with the values of slope. You can put it on there often so kids can actually see how the slope affects the line and develop some conceptual understanding of slope. So although they should already have this at this point, like I said, this is just a way to scaffold and play around with that parameter. I'm gonna go back to look at the other form so I can play around with the, yeah, this is what I want. So the slope-intercept form really gives you that same form as h of x, right? And so here we can really play around with, so suppose my value, the b value changes. Oh, that shifts the line up and down. Let's suppose my rise changes. Oh, okay. So then students can play around with this and make inferences and answer some of those same questions as they did with the 5th degree polynomial. And then I can also save that line, embed that line, and erase it and start over. So that's looking at h of x. And then we can also look at graphs of quadratics. And like I said, these are just in standard form, but you can change the forms just so your students can have that experience if they need. And so here is the quadratics simulation. Same. So here's in standard form. And of course you would, well, the basic form here, y equals x squared with a1, b0, c0. And then you can ask kids what happens when I change the b value? What happens when the c value changes? And so, oh, something about this value shifts the graph. And so the idea is for them to, it's not necessarily a math game, but it's a dynamic simulation that can help them develop that contextual understanding when making generalizations about functions. All right, you guys, talk to me. You've been quiet and that was kind of quick. What are we thinking? Is this something that you could possibly do in your classes or could share with your kids at this point?
I really want to hear your take on this coming from adult ed, because I really do think this would be useful in adult ed work.
Oh, absolutely. This is one of the concepts that our adult ed instructors find very challenging, is anything to do with functions. So whenever you say, well, you know, what can we create a lesson on or an activity on, this is the functions is always the first thing that comes up. And I wasn't aware of this Colorado website and resource, so I am absolutely in love. And I'm doing a math session on Monday with our state. And so this is definitely something I'm going to share with them.
Great, that's great to hear. Yes, awesome. Anyone else want to share? I see Stacy said in the chat, this will be great for tier 2 and tier 3 interventions. Absolutely. A way to extend and also to remediate instruction around this learning target. Anything else?
Leah, one of the messages that we give from the Kentucky Center for Math is now is the time to go deep and not wide, because thinking about how those factors change, being able to link it to the visualization with technology, now's the time to do that for our high school kids. I mean, really, what a beautiful way to go to really understand how those constants make, how they change the graph.
Right, and it's great to, if the kids are struggling with how to communicate, especially in this non-traditional instruction, give them some sentence starters as you would in the classroom. have them ask each other questions. What examples did you try? What A values did you try? What B values did you try? How did your examples differ from your classmates? And how did your examples change your graph, and in what way? So there's lots of different conversations you can have kids participate in digitally, in a chat or in a Google Meet, just to have conversations about what they see and observe with the manipulating of the graphs. So that's what you see here, some conclusions and generalizations. The article that I got the task from was really informative. They were talking about, giving kids lots of examples so that they can develop this understanding. And so I just threw some additional questions there, and then I found some even more examples on parabolas. And so that's the picture you see here. So there's another article that I found, and I kind of found this at the last minute. I was like, oh, I've got to throw this in because there was a teacher that used Angry Birds as a way to demonstrate passive parabolas. So I have never played the game Angry Birds, but it is a game. And what he found with his kids, they were immediately engaged because they were all familiar with it. There's movies associated with the characters, and they were able to write these equations from just looking at the graphs. And so I had to throw that in there, and I referenced the article there if you wanted to check it out. I thought it was a really neat read. It's from the mathematics teacher, actually from their December, January issue. And it was really interesting, the math that the kids were able to pull out of these projectiles. So just another example of how we can use digital representations in games to engage our kids, especially in this digital learning that we find ourselves in now. Anybody else want to share anything about what they've seen or saw, or any other math games you think are really cool that you would like to share that might interest high school kids? Or even beyond high school. All right, so the virtual manipulatives that I've been sharing with you guys, the links for all those are embedded within the PowerPoint GeoGebra as always. There's the PhET interactive simulations. There's lots there on their website. Those are just some of the math simulations. There's lots for science. There's also a cannonball simulation, which I think is pretty cool too, where students can play around with some physics and trajectories that also may be interesting for high school students. As always, there's Desmos and the different platforms of that, and there's the .x math virtual manipulatives that you can take advantage of as well. I'm kind of early again, just for a few minutes. If anyone wanted to share or to contribute to the conversation, or if you wanted me to go back to look at something else, I can pull it back up. What are you guys thinking? If you're still interested and still want to tune in, that will be great, because we have one more session coming in a week, and we'll be doing some more math together, looking at statistics and probability and other virtual manipulatives that are available as resources. And
Leah, what I always love about when you give us sessions are how integrated they are with the technology. And then that's always the precipitous to me to go over to see something. So the PhET, we use the PhET and the proportional reasoning Zoom sessions that we did. That's a site that has such interesting things for students to be able to, again, I keep going back to this what if situation with regards to mathematics, and being able to see how that interacts.
Yeah. There's a really cool one, since we have some time. They have lots of math simulations. The projectile motion, that's the one that I thought was really cool. Although they have more variables than you would talk about maybe in a math class, I thought it was really cool to see the launching and how they will give you parameters that you can play with. But you would probably need to give your students some more information if we were to use it. But I think it's pretty interesting to look at that simulation, and they also have this real live person there. I thought that's pretty cool, but nevertheless, that's that simulations, a little snapshot. I suggest you check it out and see what else they have available there. It's really cool stuff.
All right, fantastic. We always like to give a shout out to Leah, who puts a lot of time and effort into our sessions. Would love for you to unmute yourself and give her some feedback with regards to this.
This is absolutely wonderful. I do have a question on the PhET simulations. Do you know if they can be used with a tablet or even a smartphone, or are they completely Windows-based?
I don't know for sure. I've only used them on a laptop. It would seem to me, if I'm thinking about the program, they use probably JavaScript to launch, so I'm not exactly sure. But I would like to say that they would work on an iPad, but I don't know.
I'm getting on an iPad right now to test, just so you
Okay.
playing right now.
Oh,
Yeah.
thank you.
Well, this is live time. We can check and see. But that is an interesting question. I know GeoGebra does work on an iPad. I'm assuming that this does as well, but I'm gonna check on my phone now. Let's see if it does.
And
Yeah, I'm
the reason
trying
I
the
asked,
phone right now.
okay, is we're running into the issue where we're trying to work with adult education students virtually, and a
Okay.
lot of them don't have laptops and desktops, and all they have is an inexpensive Android tablet or smartphone. So, you know, we're starting to look at things that we can find that we can pass on to our students to use so that they can still receive a good education.
Absolutely, that makes sense. Let me see. I'm on my phone now. Let's see.
I'm starting to be able to control some of it. I just don't actually know how to run the app very well.
Okay.
But things are moving.
Yeah, I think it's successful.
I was able to shoot with the Canon on the phone. So
Nice.
it's small. It's really small on the phone, but the technology does work. That's amazing.
iPad, and so that it should work actually on the iPads, Pam. So
Oh, that's good to hear.
that'll work.
Thank you.
You're welcome.
Great.
So as we end our session, we want to thank Leah for always doing some really, really good, provocative, great mathematics for our high school folks. And you can tune in with her again next Thursday. And we'll have a session next Thursday. It's exciting to see you guys. We hope you will make this kind of an every Thursday at 1, a little respite, a little good professional development as we get together and look at things in this brave new world. So Leah, from all of us, we thank you so much. We'll see you.
Thank you guys. I really appreciate you all stopping in. I know you could be doing millions of other things, and just stay happy, healthy, hydrated. Thanks, guys. You're the best.